Now that I've introduced to you the very basics, which is the y equals ax squared, we're going to look at what happens if a number is added to it. C, right over here. Well, if we add c, it's going to change what the parabola does. We've already saw, as we look, a is going to make it either wider or steeper. It's either going to be a shrink or a stretch. If a is negative, it's going to flip the parabola. When you add c, it has another dimension, and I'm going to start very simple in order to do that. I'm just going to do y equals x squared. If you remember, that's my parent function, and I'm going to add 5 and then see what happens. So to do that, I'm going to redraw my parent function. And here's my parent function. I'm going to draw it in red. This is y equals x squared. What happens when I have a plus 5? Well, when I do that, the function goes up. So right now, the vertex of y equals x squared is 0, 0. That's because the reals are hidden plus 0 after the parent function. But when I make that 5, we'll say that's about here, that function heads up. It has the exact same shape, no shrink, nor no stretch whatsoever. But all it is it's moved up by 5 units. So the c value is what's called a translation. It causes a vertical translation. In this case, we had a plus c. We had plus 5. So this was translation up by c units. But if I had minus c, in other words, if that was minus 5, this would have moved down 5 units. So it would be down, let me just write this properly, down by c units. So to summarize, we've talked about what happens with A. We've talked about what happens with C. And let's look where we have a combination of all of these playing together. So I'm going to draw yet another graph. Here's my x-axis and my y-axis. And I'm going to draw, this time, not just the parent function, but also another function alongside it. And in order to be accurate this time, I want to make sure I draw my points on the graph. So -1, -2, 1, 2, and 1, 2, 3, 4, -1, -2, -3, -4. So first, my parent function, it's the same as we've been looking at. 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. You're going to get so used to seeing that, it's going to feel boring after a while. So here again is my y equals x squared parent function. Now I want to draw a second function. And let's see, I am going to draw it in light green. And this is going to be called the function y equals -1/2 x plus -4. Or we can also write it y equals -1/2 x minus 4. So we have all of our pieces combined. We have an a value of 1/2. It is negative. right? If we learned that should probably flip it. And then we have a -4, right? So if we look at the 1/2, we would predict it's probably a shrink. If we look at the negative, it's probably a reflection, so it's flipped. And a -4 looks like it's going to be upside down. Sorry, moved down by 4 points. And I'm realizing I did not draw quite enough on my y-axis to bring it down. So -5, -6, and I'll see if that's enough. So I actually have to draw points to plot this properly. I have an x of 0. What happens? Y is -4. So we're starting way down here. What happens when x is 1? Whoops, I forgot my squared here. Sorry, guys. Just want to make sure that that's accurate. What happens when I have a 1? 1 squared times -1/2 is going to be -1/2 plus -4 is -4.5. So not a huge stretch, right between 4 and 5 right here. Then -1 is going to be the same thing because we're squaring it, multiplied by -1, that's -1/2. -4 is -4.5. Then 2 squared is 4. 1/2 of 4 is 2. -2, I'll get -6. And same on this side. And so here is what that is going to look like. And we're going to call this we have to name it properly. It is a shrink. It is a vertical translation by 4 units down. And it is a reflection. And this is what you need to say when you're comparing it to the parent function.